So here we are in Spider, and like I mentioned, we have some more data cleaning tasks that we can do, and some other Python or other pandas functionality that I want to show you guys. So in particular, one interesting thing that you might note is if I run flights.dtypes, again just to view all of our data types here, you notice that before we converted the flight date to the actual date, but you'll notice that we also have a year, month, and day of month columns. So all of those columns exist, but they're all already incorporated into this FL date, this flight date column. So these columns don't seem to really be necessary. In fact, you could really do either or. You could either say, well, let's keep one column flight date, or let's keep 3 columns year, month, day of month. So this might be useful. If you're doing any kind of analysis that involves looking at each of these individually, then it might be useful to keep these columns around. But if you're just looking at a more holistic kind of analysis that just deals with these dates, then you might as well just get rid of these columns and keep this one column so that you're saving space and you don't have to deal with your fewer columns that you can work with. So instead, I'll show you how to, we can drop columns, so what we're going to do is remove these 3 columns. So I'll show you how to do that. So what we'll do here is, what we want to do is remove columns. We want to remove year, month, and day of month because that information is already encapsulated into this day or this FL date. So to drop columns, all we have to do is say flights.drop, and then here we say columns equals, and we give it a list of columns that we want to drop. It's quite easy to do. And one other additional thing that we'll do is I'll say inplace equals true. And what this does is this will actually modify this data frame directly. So here's the two. So what we're doing here, this as type, if I just do numpy.asType or toDateTime, that doesn't actually modify the flight's data type. It returns a new data frame or a new column, and we set that appropriately. So that's why we have to do this flight's FL date equals this, because this in itself doesn't actually change the column. It just makes a modification and gives you the result back. However, there are some cases where I can set inplace equal to true, and now this will actually modify this data frame. So now I don't have to say something like flights equals whatever. I can just say flights.drop and then inplace equals true, and that will actually change that data frame. Okay, so there are 3 columns that I want to drop. I need to drop year, day of month, and month. So we'll do year, and then month, and then day of month. So we can drop this, so I can run. So first of all, actually, we can see that these 3 columns exist now, but now I'm going to run this code. Now let's try viewing the same data types again, and we'll see that now we no longer have those 3 columns. So this is a way that we can remove certain columns that aren't really beneficial to our analysis. Alright, so that's how we can remove columns. There is also a way that we can rename columns. And the syntax is actually going to be quite similar to how we remove columns, actually. So let me give you an example of why we might want to do something like this. So suppose that, for example, for destination, this is just denoted as dest, but that might not necessarily be clear. So suppose I want to make this a bit clear that this is saying that this is the destination airport. So effectively, I just want to rename dest to destination. So in order to do that, here I can say flights dot, instead of drop, I'll say rename, and then again, similar syntax, columns equals. But in this case, we're using a dictionary because a dictionary is going to tell us what column that we're starting from and what column we want to map the new name to. So this is going to be a dictionary, and then I'm also going to do the same inplace equals true so that we don't have to deal with a return value. So what this dictionary contains is, so the key of all the keys in this dictionary represent columns that are currently existing in our database, or in our data frame, I should say. And then the value is what we want to change them to. So let me give you an example. So to convert dest to destination, I say dest, I want to map that to destination. So now when I run this, it will map the columns. It will find this dest column and convert it to destination. So notice how this is dest right now. So when I run this guy, I get an error here, and that's because this drop, I have to comment this guy out, because remember, Python data fields can persist. So if I don't remove this, then what's going to happen is it's going to say, well, it couldn't find this, and that's because we already deleted it. So now I can run this again. So this is kind of the downside of loading our data set at once. So let me run this guy again. And so now if I run dtypes, you'll see that destination has been mapped to dest, or dest has been mapped to destination, I should say. Excellent. All right, and so I will also have to comment this out, because then we're gonna run into a similar error. All right, so that's how we can rename columns and remove columns using Pandas. There's one other thing that I want to discuss, and that is null values, or missing values, or not a number. So I can actually get a list of all those. So I can say get number of null values per column. I can say something like print flights dot is null dot sum. So I can run this guy, and you'll see what I'll get is a list of all of my columns and how many null values are in each position. So, for example, for airtime, it seems that there are around almost 10,000 rows that have no airtime. And so these are examples of missing values. And there are a couple different ways that we can handle this, really. We can either set them all to a particular value, say let's say airtime equals 0 or something, or we can, in some cases in Pandas, for example, we can actually just ignore it, because when we're doing arithmetic with these null values, Pandas is actually smart enough to do this thing called null propagation. In other words, for example, if I'm adding two numbers and I don't know what one of the numbers are, then the sum is something that I don't know as well. So Pandas will do this. So let me give you an example. I'll say print. Let's look at the difference in CRS departure time and actual departure time. Right, so what I'll do is I'll say flights CRS dep time minus flights dep time. And you'll notice that if you look at dep time, there's around 8,000 rows that don't actually have values. So what can we expect here? So let me comment this guy out, so we can run this. So I'll run this. So you notice that the length is still 600,000, and that's because we are propagating null values. So anytime I reach a row where one of this guy is null, then in the resulting set, in the result here, this subtraction, that result is also going to be null, or not a number, for example. So Pandas is pretty smart to do this, but other libraries that you work with might not be that smart. So for other computations, Pandas provides a function called drop NA, and what that will do is just remove all of the null or not a null values. So I can say something like drop not a number null missing values. So what I can do is wrap this guy around, and I can say drop NA, and that will remove all the null values. So keep in mind that this is 600,000, but when I run this, you'll see that this is not 600,000, because any of the values that were null are just removed from this result. Excellent. So that is how we can remove or drop null values, so we can handle null values in Pandas. So what we've learned is how we can remove columns, how we can rename columns, and how we handle null values in Pandas. So you might be saying, how do I know all of this? How do I know all of this data cleaning stuff? Well, it turns out that Pandas actually has an entire section on its documentation devoted just to dealing with missing data. So if you go to the Pandas documentation, pandas.pydata.org, and go to /pandas-docs/table, and or if you just go to the regular documentation for Pandas and click on documentation, as you've seen, and on the left, you'll see there's a whole section called Working with Missing Data. And there's a whole section here. It's quite in depth. There's a lot of different content, and so this will introduce some of the different functions that you can use to help deal with null data. So that's useful, and you can look up information on data cleaning if you so desire. So there's also the functions, for example, drop NA is over here, how we can use that and what the different implications of that are. So Pandas provides us with a lot of information on how we can do different kinds of data cleaning. So so I just introduced a couple of them, but you can read through the documentation to learn more about how we can do data cleaning in Pandas. But what I've covered in this video is how we can do things like uh, adjust what the data type of a column should be, as well as have the different ways that we can deal with null values.